Hi, I'm Alan, and I'm an incoming sophomore at Jesuit High School. I'm the user experience game developer, and this is the Quadriceratops team.
Hi, I'm Ridge. I am a graduated student from Wilson High School. I'm going to attend Oregon State University, and I was a team leader for Quadriceratops, and I worked on game design and UI, um, user interfacing, as well as keeping the team on track and working productively.
I'm Lila. I'm a rising senior at Oregon Episcopal School, and I worked on game design and level creation, as well as source control.
Hi, I'm Elaine, and I'm a rising senior at Wilson High School. I mainly worked on game mechanics, and I also produced the game tutorials.
Okay, so how did we come up with this game? Well, our game, Getting Scrappy, was created off of the idea of wanting to create an educational recycling game to teach people how to recycle and how to correctly sort their garbage and their recycling. So we originally got the idea from the game Papers, Please, which is another game that we played on the computer, which is sorting. That has to do with sorting, and there's lots of advanced game mechanics and art. And we really liked that game because it was sorting and it was similar to something that we could translate to recycling. From that, we came up with some ideas on how we could implement into our game, and we liked the idea of a conveyor belt. After we did some research about waste management facilities and saw that they had a conveyor belt with all of the items coming into the plant. After doing some more research and more ideas floating around throughout our team, we decided that our initial goal was to be the user was going to be a worker at a waste management plant, and they were going to be sorting through items coming on the conveyor belt. But then we did some more research, and we played some PBS Kids games and tried to get some more ideas. We played the game Fetch with Rough Ruffman, What Are We Doing, which had conveyor belts that we wanted to see those mechanics of a video game, as well as an actual recycling game on PBS Kids called Recycle Roundup. And we got some more ideas for how we wanted our game to work. And we decided that instead of being a worker at a recycle plant, we wanted to be a person in their home sorting their own trash into different bins. And so it could translate directly into the user's life so they could learn from this game and directly impact how they lived after playing this game. So now that you know a little bit about our game, I'll show you an actual live gameplay. So this is our game. This is the main menu, and I'm going to go into level 6 to show you a little bit of more of the advanced parts of our game. So you can see the conveyor belt in the background, and we have our 4 different bins: brown for trash, blue for recycling, yellow for glass, and green for compost. And then in this level, it's showing the tutorial about how to implement this new feature, the freeze button, for level 6. So this freeze button will slow down the game a little bit, so then you can have a chance after the conveyor belt is moving pretty quickly with the items. So let's have a gameplay, and I'll show you how it works. So this first item is trash, so let's move it there. We have another trash item. Now we have a third trash item. Here's a metal item that can go in the recycling. Here's a compost item. Let me make sure I can grab it. Let's click the freeze button to slow it down. If I right-click on this bottle, it'll split the bottle to get 2 different things. And if we let the items go off the screen, we'll actually be going down in score. And then here's the pause button. Up on this top bar, we have our level number, the time, an animation that goes with this time, as well as a score and our high score. And then if we can click resume, we'll be able to see more items. We'll move something into glass, something into recycling. And then we can use the freeze again, slow this down a little bit. And then we can go from pause to the menu screen. And in the menu screen, we can play the last level that we ended on or level select. We can choose any of our levels that we've unlocked. Yeah, and then we can go back to the menu and we can quit our game.
So during this project, we had a variety of challenges to face. Sometimes computers would crash and progress would be lost with the game project. Other times computers would act very slow, holding up apps involved in development. The solution was to constantly save progress to mitigate losses. Furthermore, work times were restricted as team members had to leave early or start late due to scheduling problems. We resolved this by just working harder in the time we had together. Another example of a challenge we faced was communication. It's hard to keep tabs on one another virtually, so sometimes fellow members would be hard to reach. Our solution was to follow a strict order of communicating through chat or Discord status. Example, idle status, online status, or just saying in chat how long we would be gone for. Getting Scrappy is a game involving a lot of mouse work in the form of dragging and dropping. These limits on player interactions make fluidity of game crucial to providing a satisfying game experience. We implemented a ray tracing method combined with a color over method during our drag and drop, and the ability to tell players that an item was being selected and moved. Here's some code that shows what we've been doing with the drag and drop. As you can see, the mouse over color is green. Once you have the item in your mouse's control, it's going to be white, so it's going to be its original sprite color, and it's going to be dragged wherever you want. And once you release your mouse button, it stops moving completely. We also implemented a 2D surface effector on items through the conveyor belt system so that items can pass through on or off of the conveyor belt. As you can see in here. In the level design, game menus were generated through usage of canvas panels, linked with previous scenes in Unity's assets. Pause menus were created through usage of canvas panels, linked with previous scenes. Pause menus were created through a stop-motion timescale coded into canvas scripts. One of the more unique user interfaces can be seen with the freeze button, as it involves a limiting counter for number of presses and slowing down all game items by a uniform timescale.
So as Alan was saying, we have a single multi-layered scene instead of a scene for each level. So instead of having 9 scenes, we only have 1. What this means, though, is that upon completing a level and moving up and leveling up to the next one, we need to adjust many things via script. Many of these things can be seen in the timer script shown right now. For example, we are adjusting the countdown up that you can see in the UI, and we're also adjusting if we can see the level complete menu, if we can see the game complete menu, and which bins we can see per level. For example, with the bins, in level 1, we only have the trash and the recycling bins. However, in level 3, we introduced the glass bin. Sorry, in level 4, we introduced the glass bin, and in level 5, we introduced the compost bin. The freeze button is actually implemented in a different script. But the communication between these scripts is crucial, and that's why we used many static variables. And in this timer script, you can see that we're changing, especially in the level up and the level complete functions, we're changing the static variables such as the level number, the bins available, and also the points that the player currently has.
In Getting Scrappy, we wanted to teach some of the more complex rules of recycling. One such rule involves putting bottles and their caps into different bins. While playing, the user has to right-click on bottles. The cap pops off, and then the user can drag the cap into the trash bin and the bottle into the recycling bin. So, in the code, when an item is right-clicked, we check whether the item is a bottle by comparing it to the sprites in our game that are bottles. If it is, we instantiate a new prefab for the cap and change the current sprite to be an uncapped bottle. We edited new sprites so that each bottle had a distinct sprite. Currently, this feature works for the milk carton, the laundry detergent, and the water bottle. One of the most fundamental game mechanics is the repeated generation of the items off-screen on our conveyor belts. This is achieved through instantiating an item prefab. This item is then moved off-screen, assigned an image, and given the appropriate tag. For instance, trash or recycling, or if it's a bottle, it gets the tag multiple. Cool. And then should I do something specific for the tutorial or not? Do we care?
You could just talk about the screen and like how like you make everyone click continue or something like that.
Cool. Okay. For each of the first 5 levels, the user is shown a little tutorial, and they are shown instructions that tell them what the rules are for that level.
For my job on the team, I worked on a lot of the user interfacing and user experience. I worked on getting the buttons in the right places, allowing the screen to have the right arrangement so everything could be seen. I worked on making sure that all of the features that were implemented by my team members were able to be seen and used properly by the user. One of those specific things was creating the sprites on the items. Before we had the sprites, we had boxes with tags. And that was not super helpful when determining where to put items. By putting tags on the items, I was able to determine which tag was on each instantiated prefab from a lane script, and then associate a specific sprite or a random sprite from the collection of ones that worked with that tag. Here is the example script that I used. After determining which tags were available for each of the different levels, I was then able to determine each item that was spawned and figure out what the tag was. Based on what the tag is of the items, I was then able to create the sprite of the image on top of that instantiated item. This allowed us to have different types of metal items, different types of plastic items, as well as compost and trash, and paper and glass. So we had a lot of different items, and we're able to add another feature that was in the game of not having the same exact items that went into the bins, but different items that had the same amount of points. So functionality-wise, they were the same, but to the user, they were different. And that's something that we used in this game to like add a little spice to make the game a little more interesting for the user. But in addition to user experience, as team leader, I had to focus a lot on communication, especially because our team never met in person. We were always virtual. We didn't know each other at the beginning of 3 weeks ago, and the beginning of our project time. And from that, we had to come up with different strategies to get to know each other and to acclimate and work as a team. So from that, we had daily meetings in the mornings to figure out what we'd worked on and what we were doing. In addition to weekly, after the weekend, we talked about how our personal lives were, just to get to know each other a little better, since we weren't having lots of discussions in small talk because we were not near each other. We used a lot of different resources to stay organized. Our first one was Discord. Through the NWAPW, we were able to use a Discord channel all for ourselves, where we were able to communicate frequently, have this text channel, send links and images, and we also had our own voice channel right here, as you can see. We were originally named Educational Recycling Game, but over time we changed our name. And we were able to stay in communication either through communicating with talking or typing throughout the 3 weeks of working together. We also used the application Trello to stay organized with all of our tasks. You can see we have different tags for the different days, the different weeks we were doing stuff. Blue was our first week, dark purple was our second week, and green was our third week tasks. And we were able to stay organized, and each person had their own list of tasks as well. And this was a way for us to stay organized as well as stay in touch with our advisors to make sure that they knew what we were doing. And from this, we were able to communicate based on what we had completed, and even if we weren't able to communicate directly with each other, we were able to see how the progress of our project. We also used a lot of source control to share our code. Using Unity, there were a lot of different files that Unity creates, and we were able to stay on task and stay organized by using this source control on GitKraken connected to our GitHub account. So as you can see, we have a lot of different branches that connected to each other, and Lila was able to stay on top of it and stay organized and making sure that everything was where it needed to be while everyone coded on different branches and combined into the master for our final project. So we have lots of branches, lots of connections and merges, and using GitKraken and Terminal, we were able to get all of our code organized. And our game, Getting Scrappy, is a product of all of our teamwork and communication, as well as our dedication to coding and wanting to teach others about the importance of recycling in our community. Thank you for watching, and we hope you get to play.